everyone. So here we're going to start with numerical solutions for velocity time graph. So here we are going to see one example of velocity time graph. So suppose this is one graph, velocity time graph, and the body has started its motion at this point and ends at its motion at this interval of time. So while having this motion, you can able to see when we have plotted the graph, it has covered different distance. So now with the help of velocity time graph, we can able to find out total distance traveled by this object, displacement of an object, and acceleration of an object. So these are the three quantities we can able to find out with the help of velocity time graph. So if we want to find out total distance traveled by an object, we are going to find out the area of this shape of a graph, which is trapezium. This is triangle, this is another triangle, and this is another trapezium. So when we are going to find out the area of these all shapes, we can able to find out total distance traveled by the object. Then if we want to find out the displacement, then what we're going to do in this graph, if you can able to see that this is this part and this part is the positive part, and this is at the negative quadrant of this graph. So what we are going to do to find out the displacement, we are going to add positive areas, means positive quadrant areas, to, and we are going to subtract this negative triangle and this trapezium. Means when the negative quadrants are going to get subtracted with the positive quadrant in a velocity time graph, we can able to find out displacement. Then to find out the acceleration, what we do, suppose you want to find out the acceleration of this part of the graph, then what we will do, normally we will find out the slope at this point, and then we can able to find out the acceleration with the help of velocity time graph. So now we are going to see some of the numericals. So first numerical is given here. So this is one graph, velocity time graph is given here, and with the help of this graph we are going to convert it into displacement time graph. So to convert it into displacement time graph, what we have done, that we have find out area of this graph at different time durations. So this velocity time graph is for 0 to 4 second, and velocity is given in meter per second from 0, 1, 2, 3, 4 meter per second. So for every quadrant, means from every quadrant we are going to find out the area of every triangle. So now for example here, velocity of a body at t1 second is 1 meter per second. So therefore displacement of the body at t1 second is the velocity into time. So velocity is given here as 1 and time is also 1, so it become 1 meter. Then velocity of a body at t2 second, means at this second, what is its displacement we are going to find out. So displacement of a body is equal to 2 into 2, so it's become 4. Similarly at t3 second, when we are going to find out the displacement, so displacement becomes 3 into 3, it becomes 9. So when we are going to plot the graph, it comes in a curved line with the help of this quadrant. 1, here 4, and then 9. So 1, 4 and 9, when we have plotted for 3 seconds, it comes in curved line. Then next we are going to see the velocity time graph of a car is starting from the rest. So this is the graphical representation of graph as it has started from the rest from 0 to B, then at a constant motion from B to C, and then again it is going to retard from C to D. So question is given here, so how is the distance traveled in any part determined from this graph? So by finding out the area of this triangle, then area of this rectangle, and then again the area of this triangle, we can able to find out displacement with the help of this velocity time graph. The second question is given, compare the distance traveled in part BC with distance traveled in part AB. So this AB part and BC part, we are going to find out its displacement. So here we are going to have the solution. So for the first part, as it is given, so this is the first part. So distance traveled in any part of the graph can be determined by finding the area enclosed by the graph in that part with the time axis. So when we are going to find out the area, we can able to find out displacement. Then for the next part, distance traveled in part BC is equal to area of rectangle, and that area according to graph has come V0 into D. Then the distance traveled in part AB, again we are going to find out the area of that triangle, and after solving we got the area as half V0 into D. So when we are going to compare, we are going to get 2:1. Then the third question is, it is given here that which part of the graph shows motion with uniform velocity and acceleration? So in this part, BC shows motion with uniform velocity and AB shows motion with uniform acceleration, and CD shows motion with uniform retardation. This CD shows the retardation, AB shows the uniform acceleration, then BC shows the uniform velocity, and CD shows the uniform retardation. Then the next question, again a velocity time graph is given and you have to find out the acceleration at every part. So this velocity time graph is given from here to the BC and then again to CD. To every part we are going to find out the acceleration. So to find out the acceleration, what we have to do, we have to find out the slope of AB, then here in BC, and then this CD. To find out the slope of AB, what we have to do, we have to divide this part from B to here to this part, means 30/4. This is for B it is 30, and for this part is from 0 to 4, so it becomes 30/4, which is 7.5 meter per second. Then to find out the acceleration for the part BC, as we can able to observe that this is uniform velocity, so acceleration becomes 0. Then CD, so CD is uniform retardation. So to find out the retardation, again what we have to do, the C is 30, and from 8 to 10 it has a time gap of 2 seconds, so we have to divide 30/2, and as it is retardation, it is in minus sign, so it becomes minus 15 meter per second square. Then the next part, displacement in each part you have to find out, AB, BC and CD. As we know that to find out the displacement, you have to find out the area. So for the AB part, area of triangle will become 60 meter per second. Then for the BC part, area of this BC part, this is the area of rectangle, then it becomes 30 meter. and then for the CD part, then again it becomes triangle, the area of triangle, which is equal to 30. Then to find out the total displacement, what we have to do, as these all different shapes are in positive quadrant, so we have to add. So at last we have added 60, 120 plus 30, it becomes 210 meter, which becomes total displacement of an object with the help of this velocity time graph. Then next, so this question states here that a ball moves on a smooth flow in a straight line with a velocity 10 meter per second for 6 seconds. At 6 seconds, the ball hits the wall and comes back along the same line to the starting point with the same speed. So this means here that when we are going to plot the graph, then we will understand. So ball has started its motion with 10 meter per second. So this is, suppose this is velocity time graph, and from here to here this quadrant shows 10 meter per second. So when ball is going to start, it has started with its velocity of 10 meter per second. Then at this junction, means at 6th second, ball hits the wall and returns back. So when ball is going to hit the wall, what is going to happen? Its velocity for a moment is going to become 0, and again it will return back with same velocity. So means that when it has started traveling with 10, then when it is going to return back, it will also return back with same speed of 10 meter per second. But as it is returning back to the path, we are going to have the negative quadrant. So you can observe here in this graph. So this is a two parts, from 0 to 10 and then 0 to minus 10. So from here to here motion is in positive direction, and at this junction ball is hit the wall and returning back. So here you can able to observe that now the motion starts with negative quadrant. So now for this graph we are going to find out the displacement. To find out the displacement, we got the two areas, one, and now here to here we have the second area, or area of rectangle we are going to find out. So velocity, distance is equal to velocity into time. So velocity is 10 and time 6, so it becomes 60. Similarly for the another part will be also 60. Total displacement or distance traveled by this ball is, so distance traveled by this ball will be, when we are going to add first and second quadrant, so it become 60 plus 60, 120. But when we are going to find out the displacement, so as the ball returns back to the same point, displacement becomes 0. As well as with the help of graphical representation, what we have learned that when we are going to subtract the negative quadrant with the positive quadrant, then what is going to happen, that in that case, as positive quadrant shows 60 meter per second and negative quadrant also shows 60 meter per second, so when we are going to subtract, it will also become 0. So from both ways we have come to the conclusion that when the ball returns back to the same position, its displacement becomes 0. Then for this figure again, so again this is another velocity time graph. We are going to find out the displacement at t6 seconds. So from here to here t6 second. So first question is given, state the nature of motion of a particle. So to find out the nature of motion of a particle, so from 0 to 4 second, so here from 0 to 4 second, as you can observe that it is a uniform acceleration. Then 4 to 6 seconds, so then from 4 to 6 seconds we can observe that it is uniform retardation. Now we have to find out the displacement of a particle at 6th second. from 0 to 6. So we can observe that this is one triangle we got. To find out the displacement, we are going to find out the area of this triangle, half base into altitude. So this is the base, and from here to here this is the altitude. So half 1 by 4, 1 by 2 into 4 into 2. So displacement. So the distance traveled by this object becomes 4 meter. Then if we are going to compare the distance traveled by the object in 0 to 4 second, and then again from 4 to 6 second. So when we are going to find out the distance traveled by an object from 0 to 4th second, so again 0 to 4 second we have to find out the area of this triangle, and then 4 to 6 second we are going to find out the area of this part of the triangle. And when we are going to compare the areas of both two, we will get the ratio as 2:1. Then we have to find out the acceleration from 0 to 4th second. To find out the acceleration of 0 to 4 second, we have to find out the slope. So to find out the slope, what we have to do, we have to divide this part by this part. So from here to here this is 2, and now from here to here 4 and 6. So 6 minus 4, it is also 2. So then it become, so from 0 to 4 seconds, so from here to here, so this part by this part, so 2 by 4. For the acceleration it is 2 by 4, 0.5 meter per second square, and for the retardation it is 2 by 2, which is 1 meter per second square retardation. So with the help of this graph, so we can able to find out acceleration as well as displacement. So this means that in this all numericals of velocity time graph, we have seen that when we have to find out the displacement of any object with the help of this graph, then what we have done, we have found out the area. And when we have to find out acceleration with the help of graph, we have found out the slope. So this is the basic idea with the help of velocity time graph. Thank you.